let me get started. I'm Sanket. I'm the co-founder of BlobCity. I'm also the CTO and the creator of our database. And to say it in a single line, BlobCity is an all-in-one database that we created. So in the power of data analytics and simplicity, the winning combination, this is where precisely where BlobCity fits in. So we know today that data is everywhere. We can see it literally anywhere we look, there is data. It's also the new oil. It is trapped in multiple formats and it is growing fast, right? And somehow we have managed to create hundreds of products to house this data. So all of our data is sitting split across these different products and we have no ability to collectively analyze it. This is where BlobCity comes in as an all-in-one database. So if you have the scenario of having your data being put in different products, or you think you need to put it in different products because each product supports a specific format of data, you can choose BlobCity as a database that natively supports 17 different formats of data. That includes JSON, XML, it includes your PDF documents, image files, video files, also geographical information data, PDF, logs, syslogs. All of these formats can come into the database in one manner, and it's seamlessly. So when you put in a PDF, you don't have to tell the product you're putting a PDF into it. It recognizes that you're injecting a PDF. It will automatically parse it, gives you the ability to search through this PDF. We also offer, in addition to this, a disk-based storage and an in-memory storage. So you can store these 17 formats of data either fully on disk or fully in memory, or partly on disk, partly in memory. Memory allows you ultra high speed of analysis, so it's low latency querying. Disk gives you low cost storage, but still good performant, reasonably good performant querying as compared to, it's very competitive with other products. We have customers today like Jaguar Land Rover who use our technology to price their products, to actually design the vehicles and price the vehicles across 42 different markets. We have customers like Underwriters Laboratories, which is a fire safety certifying company, who certifies buildings like these hotels for fire safety, which means if we are sitting in this room right now, UL has probably certified it that it's okay for us to sit, and if there's a fire, we can evacuate really quickly. The data analysis required for checking for egress and burn rate and everything is pretty complex mathematical models. So it's like if you ignite the carpet right now, how many seconds would it take for this room to be in flames is an ultra complex mathematical model. And the data comes through various sources. They use our product to analyze it across the globe. We are, as a background for BlobCity, we are an IIM Ahmedabad funded company. We are also Gartner Cool Vendor in database management systems in 2016. We also graduated out of NetApp Accelerator after the IIM funding. We are Docker certified. You can get BlobCity on the Docker store. We are also IBM Power 9 certified. That's for large enterprises who want Power 9 servers. They can get BlobCity on. It's already certified. BlobCity also is open source. So we are open source under the GNU Affero General Public License. We do welcome contributions. What this license means is neither BlobCity nor anyone can have a proprietary commercial version of the product, right? You can host BlobCity on your data center and host it in a commercial manner, but if you tweak the BlobCity source code, you need to make your tweaks open source. That's all it is. And whatever source code of BlobCity we run on our cloud is exactly the same copy that's available on GitHub for you all to use, right? So we are actively looking at contributors to come in and contribute into the repository. You can just search BlobCity GitHub and you should find us. So BlobCity can be taken basically on-prem. So you always have the choice of taking it, install it on your servers. It is also treated on-prem if you take your server on DigitalOcean and you run BlobCity on it. For us, it's like you're taking on-prem. On the cloud, we also offer multi-tenant cloud, which means it's a shared deployment. We host the infrastructure. You don't pay for the infrastructure. You load your data and you just analyze the data. And this is available across all DigitalOcean data centers as of today. You can go on our website and purchase any data center you want. It's the same open source software that runs on the multi-tenant data center. And the interesting thing is, this is where it gets very simple. Right? So most companies do not like to increase the cloud infra or add in a lot of data into the cloud infra because it costs a lot of money to store data on the cloud. Right? With BlobCity, data storage on the cloud is free of cost. We only charge for what you analyze. We don't charge for the data you load or you store. right? Only for the ones that you analyze. And the cloud is multi-tenant, which means it automatically scales up and scales down. The scale down is essential so that we make money at some time. So that's why we scale it down where you're not using it. But when you're using it, it automatically scales up. And it's automatic clustering provision for you, so you don't have to configure anything out of the box. Fire a query, put in any amount of workload that you want, and you can be confident that we will scale it up to service your workload at the desired performance that you require, right? But pay for what you analyze is only at the rate of, the way we charge it is just simple $10 per million rows that you select. So $10 is a minimum billing that you pay us irrespective of how much data you store. And based on the number of records you select, we charge you $10 per million records you select. Now let's say you take a table having 1 billion records and you fire a sum query on a single column. So the response of the sum query is a single entry, which is a sum. We will not count it as 1 billion records that you summed, we'll count it as 1 record that you extracted. So it will only charge you for 1 record, right? So whether a customer has 10 GB of data or on the cloud or 1 terabyte of data on the cloud, if both do 1 million row selects, both pay exactly $10 in that month. The same two customers, one has 10 GB, other has 1 terabyte of data, they both do 100 million row selects, they both pay $1,000 a month. Right, so it all depends on what you're analyzing, not what you're storing, right? DigitalOcean, we've been on DigitalOcean for a while now, and we're also part of the Hatch program. And it has really, really benefited us in several ways to be able to do this automatic scale up and scale down. So what's really essential for us is we save on compute hours when you're not actually using the compute. Data storage is very, very cost effective today. It's not the most expensive piece. The RAM and the compute is the most expensive piece. So we can afford to store data at minuscule expense, even though you don't pay for it, right? But when you want access to that data, we need to provision that access the moment you want it. We need to run the analytical query that you want the moment you want it, right? And to do that, we have to do a really smart, innovative way of scaling up our infra and scaling down our infra. And some of the next slides actually involve how we use DigitalOcean to do the scale up and scale down, right? So at a basic architectural level, we have load balancers on the top, right? So the request goes to one primary load balancer. From the load balancer, the load gets distributed across servers. One of the servers could be smaller server, other could be larger server, and this is all in a cluster of servers. Typically, each node in the database, we operate as 2 active nodes. So each node is replicated as 2 active nodes. One is a larger one and one is a smaller one. And I'll get to why it is like this, right? But what's interesting is DigitalOcean gives us floating IPs, which means if our primary load balancer ever fails, we don't have to go back and change the DNS records or anything of that sort. We can just instantaneously, within few milliseconds, flip the IP to another load balancer, which is already sitting as a backup balancer to take up all the workload in case the primary fails. So we have 100% redundancy there, giving you no downtime in case of even a physical server failure at the load balancer level. Now, cost is very important, right, for us, because we don't charge you for the data storage, and we don't even charge you for the compute. We just charge you for the number of rows you select. And if you're firing a sum query across 1 billion rows, we are taking a lot of compute to find out that sum, but we are charging you only for selecting 1 record, which will well fit within your $10 price point. So how do we do this? We need to make money at the end of it, right? We can't have a lot of servers working to service your query. So cost is the biggest consideration for us, and optimizing it is very, very big. And some of the learnings on how this is done can, be used in the various apps that you also build, and how you use DigitalOcean, right? Can also be important in how you cost it. So, as I said, imagine the database to be like, this is one node of the database. So there's a left side and a right side. I'm going to make it simple. So the left side is a larger node, the right side is a smaller node, but these nodes have replica data. They have exactly the same data on itself, right? When you fire a select query on this structure, the select query only fires on the larger node. Why? Because the smaller node is not capable of giving you responses for the selects you do. It's not large enough to service. Select is expensive, inserts are cheaper. Insert just goes down to disk, it writes it. People fire complex select queries. You can't actually fire complex insert queries, right? You're just inserting, and you can fire a lot of insert queries, which is okay. We'll scale it up and we'll still accept the inserts, but you can't fire complex insert queries. Insert is insert. Select, you could have joins, you can have aggregates, you can have select query within a select query. So it's a more complex execution, requires a lot of compute. So the premise I want to establish is the data goes to the block storage, and the block storage data across these two separate nodes is 100% replicated at all times. The database ensures that this happens, right? The interesting part is the smaller server just costs us $5 a month in DigitalOcean, and it's more than enough typically to handle most of the insert workloads, because the block storage volume attached is exactly the same, and to insert, we don't really need a lot of compute. We just need to push data to the disk, right? But what happens when so what happens when this left side server is not able to scale up to meet your select demands? You're firing a lot of select queries, a lot of customers are coming and firing select queries, it's running out of compute, it's running out of RAM, we need to scale up the system. So when we want to do this, what we do is we turn off the server on the right side first. We turn it off. The $5 server, we turn it off. Then we scale it up to the extent we want, which is estimated using certain amount of intelligence on what should be the server power based on the select queries that are coming in at this point in time. Once that's scaled up, you may have some data that got inserted on the left side server, which the right side server doesn't have. So we're going to do a disk sync, right? So we're going to sync the disk from the left side server to the right side server. Once the right side server is in sync with the left side server, we can now move both the select and the insert workload to the right side server. We are going to move both, not just the select. Right now, the right side server is taking all the workload. We power down the left side server. After we power down the left side server, we downscale the left side server, power it up. After it's powered up, we again do a reverse sync. Now we sync from the right side server to the left side server. That's only incremental data that got inserted in the right side server in the 60 seconds that the left side server was down. Right? That's all it takes us to basically resize this infra, typically less than 60 seconds. It could be 25 seconds, 30 seconds, 40 seconds, depends on data center and depends on what is the demand at that point in time, right? Once this is synced up, now again, both servers take all inserts, so they are consistent at the disk level, but only the right side server takes all the selects. But this time, the ability to deliver selects is much larger than was with the before setup, right? So we have scaled up the infra at real time with zero downtime and without actually costing us any extra amount of money. So in order to do the scale up at runtime, the only incremental cost we have is that extra server of $5 a month, right? And with that $5 a month cost point and that server being reasonably performant to accept most of the insert workloads that we get on our cloud, it's really saves us a lot of money. So this is where DO comes in. So DO really allows us to do fast and cost-effective scale up and scale down. And this is really crucial to a business. And it's to the extent that the minimum $5 a month price point allows us to at least save 30% on the backup servers that we would otherwise run on other data centers. So these are the few points I wanted to mention and some of the learnings I want to share here on what BlobCity is, how we simplify for you to put in data of any nature, collectively analyze it, and also how DigitalOcean really helps us go to the next level in doing this in a very cost-effective manner that allows us to offer free of cost data storage and bill only for the analysis that our customers run. That's it. Thank you. Are there any questions? I'm happy to answer them here, or we can take them offline here.
So you have got the client data. So what you might be having multiple client data. So how do you ensure that that there is no data is not leaked to some other client, or
that's built into the product. So it's very strict roles and permissions which are controlled. So you have to, every request you make onto the database requires you to authorize yourself, and based on that authorization, you're only going to get access to the information that you're authorized to, right? And because our source code is like open source, our customers can actually go and check and verify that the authorization mechanics are correct. And at the disk level, it's encrypted. And we do allow our customers to feed in their own custom encryption key. So based on your login account, you can supply your own custom key so that even we cannot, read your data, and we do not save the key. You pass the decryption key with every request, right? And we don't save the decryption key.
So it's so your algo look into trend, or the client has to give you some insight.
Yeah.
So means how does it work basically? So you have the data. So new data is coming. So so what's the new trend? So does your algo in itself looks at the new trend which is coming up?
Yeah, meaning how to scale up and scale down?
No, it's the trend means the data means what the data is showing basically. You analyze the data, right?
Yeah.
The data analytics.
Oh, we don't analyze.
You don't analyze.
Customer writes the analysis query. We give a database.
Okay.
Right? We give you the ability to throw this data in a multi-tenant cloud infrastructure, right? Which takes care of scale up and scale down automatically. So you have to imagine this as an infinite database.
So I still need to have my own analytics team. It's not outsourced.
Yes.
Okay.
Yes.
I just want. Thanks.
Just take those two questions. Hi Sanket, my name is Vineet. Great presentation.
Thank you.
So my first question, I actually have two questions. I don't know if you have enough time, but the SQL, and so basically you have a unified database which can store SQL and NoSQL, and you have your own query language. But the reason conventionally these two databases are considered different is because the structure of query is very different. For instance, in MongoDB you have projection, subdocuments, and things like that. And SQL does not. SQL looks at a flat normalized data.
Correct.
And NoSQL doesn't.
Correct.
So if there was a solution to bring together both, why, how are you doing it? And then what's the trade-off? Is there a trade-off? Is there a catch-22 here?
So you can't query everything in SQL, honestly, right? There is a limitation to that. We pre-create certain meta. So like if you throw a PDF document, we will pre-create a column called _images. Right, which will have all the images in the PDF, _P, which will be having all the paragraphs inside the PDF document. So it allows you to select, like say, select _images from, the table, which gets you all images in a PDF document. But if you really want to do the advanced querying, you have to write stored procedures in Java or Scala language.
Got it. So basically you try to normalize the JSON data. Under the hood you're doing that, and then allowing SQL queries on that. My second question is that little round robin thing you showed where you scale up one side and scale down the other side. Why isn't conventionally, that if that is the economics of that works out, then why couldn't you just do it on any database, be it MySQL or any other, and then just give us hosting solution for that? So I'm saying that trick is should be applicable to any database.
No, not really. With some you could do it, but what's really important is the product in itself needs to be able to handle this load changing. So like the product is deciding that the left side node receives all selects at this time, and both nodes receive insert. Then during the migration, the left side node receives all the selects and the inserts. Then that workload is slowly shifted to the right side node, and then both come back to normal, right? So that decision is taken, that's an algorithm built into the database, right? Which you would not get in a MySQL.
Okay. One last question. So you said it's a select and insert. There is a composite query, which is an update, which does a select and then
of course. Of course, insert and DML, that's what I mean. So, yeah.
Hello, my name is Nikhil, and my question is, how much time does it take for you to downsize the server? What's the time gap between the upsizing and the downsizing?
60 seconds.
60 seconds?
60, but the customer does not notice anything.
Okay, so we don't notice anything.
Yeah, it's zero downtime for the customer, totally transparent. You have fired a query, it's going to respond.